Hello, I'm Nobby Clark. Welcome to my workshop. A different view of the workshop for a change. I've just got a new nice stool for the desk here. The original chair I had was an old office chair, but because of the constricted area I've got here, I couldn't actually swing the chair around, so I couldn't easily sit at the desk. So I thought if I got the slightly smaller chair, I could actually take advantage of this little bit of space in front of my new wooden toolbox and next to the surface plate, so I can actually sit here and work at the desk and also use the surface plate to set up workpieces with my height gauge and measuring tools, etc. Also in the background's my workshop radio, most useful tool in the workshop to have some music in the background while I'm working. Obviously not while I'm filming because of copyright problems. But anyway, there's a few things that I wanted to mention in this workshop. The main thing is that in October I went to the Midlands Model Engineering exhibition and took advantage of the fact that Myford were there, and I bought a new motor pulley for my Myford Lathe, and I also bought a sectional drive belt from the shaft to the counter shaft in case the original one ever breaks, and this sectional belts are much easier to replace without taking the whole lathe apart. Now, for quite a long time now I suspected that there was something wrong with the pulley on the motor of the lathe. Myford lathes are very noisy anyway, but mine just seemed to be exceptionally noisy, and I often felt there was something sort of rubbing while the lathe was running. Whether it was the edge of the pulley or the belt, I wasn't absolutely sure. I did fiddle around with it quite a number of times over the last few years and could never really get it running really well, and it always seemed worse if I changed the belt up to the higher speed range as well. So the pulleys are quite expensive items, but I thought it's really going to be worthwhile if I can improve the operation of the lathe. Now I've already fitted the pulley to the lathe. I didn't film this because it's in a bit of an awkward position really, right next to the bench that has my milling machine on it as well. It would have been difficult to have got my camera into a good position to show it, and it was actually a very long job to do it. I also had to make a new key for the keyway on the pulley, and also, as recommended by one of the gentlemen from Myford, the pulleys only have one grub screw in them to lock the grub screw onto the key itself. Their recommendation was that you drill and tap a hole on the opposite side of the pulley and put a second grub screw in. This, they said, can make a difference in holding the pulley in a really nice tight position, although the pulley was reasonably tight going on to the shaft of the motor anyway. But I did what they suggested, drilled and tapped a hole through the pulley and did a bit of experimentation to find out what the thread was. I discovered that the grub screw provided with it was a 0 BA size. Well, I don't have any grub screws in this size, but I did have some OBA screws, so I cut a section off the end of one of these screws and then sawed a slot in the end so that I could use a regular flat screwdriver on it, and this worked perfectly well. Subsequent to this, talking to a friend only early today over WhatsApp, he mentioned to me that OBA actually is almost the same as a 6mm screw, only that the BA size is the peak of the thread is actually rounded off, so you could actually use a 6BA grub screw to do the same job. But I had already done this before the conversation with him anyway, so but it worked out fine. I'm going to move the camera position so I can show you how I've set the pulley up on a lathe chuck, just to sort of demonstrate what I actually found was what I think was the problem. This is the pulley that I've taken off the lathe, and I've set it up on a 5/8 of an inch bar into the chuck of the Myford, and they're using this scribing device here, and I don't know how well you're going to be able to see this, but I've set the point here sort of close to the edge of the pulley. Now if I turn that round, that's its sort of closest position. You can hear, or hopefully you can hear it rubbing and then moving away. So now there's actually a gap between the side of the large pulley, and it's a reasonable size gap. I'm going to try and move this against the smaller pulley wheel and see if there's any difference there as well. You see there is also rubbing there. I mean that the small one is the one that's being used most of the time for the lower range of speeds, and that's basically what I suspected, that this was sort of running out of true and causing me these problems. I mean the lathe is still quite noisy, but nowhere near as noisy as it was before. I'm just going to move this out the way, and I'll undo the little grub screw in there. I'll take the pulley off. I mean, I'd had examined the pulley before, and it's in, as you'll see, in pretty shocking condition. If you can see clearly the end of the pulley here, it's in terrible condition. It's obviously been beaten on with something in the past, and you can see is a huge, I don't know if you can see that here, probably see that clearly, there's a huge amount of damage to it, even here as well. So I mean the pulley is quite, even on this side as well, it's quite shocking actually how bad it is. It's obviously had a very, very hard life. When in previous times I've managed to remove the pulley and sort of refit it again, but when I had to remove it this time, I actually had to use a pulling device to get the pulley off, because it was so tightly in position I couldn't pull it off by hand. So you see, it's a 5/8 shaft on the motor, and here you can see there's the little grub screw here, which I mentioned was a 0 BA size, and what Myford recommended was that you drill a hole on the opposite side, drill and tap that for another grub screw. As I've got a range of metric grub screws, I was going to use a metric one. Obviously at that point I didn't know that the OBA was the same as or virtually the same as a 6mm grub screw, so I very, very carefully marked across here to get it exactly opposite this one, although if it was slightly out I don't think it would have made any difference, but I marked across here and then down the side, and I set this up in a vise under my drill press and then drilled and tapped. It's very easy to do because this is cast iron, so it actually drills and taps quite easily. But anyway, I'm sort of really pleased that I've changed this over now. I'll just swing the camera in and show you the side of the lathe so you can see it in position, although it's not going to be very interesting. But bear with me just a second. Well, there's the new pulley in position, running very nicely now. I think originally the pulley was rubbing against this part of the sort of inner cover. There's obviously a bit of movement in here, but I guess that needs to have that. But this isn't rubbing down the back here anymore, and the belt doesn't appear to rub either. And I found that the lathe does seem to run a little bit quieter than it did before. I don't get the horrible noises I had in the past, which to me always were a little bit on the worrying side. But there we are. I mean, I'm sorry I didn't sort of film any of the work on this, but I didn't find it sort of particularly easy to fit in the end. But glad it was really worth the time to do it and get the new one on the lathe. So quite pleased with the outcome here. I've just run the lathe for a bit, and we should have to take my word for it that it is actually running a little bit quieter than it was before, although I suppose anyone that's familiar with a Myford lathe knows how incredibly noisy they are anyway. See, the lathe has a clutch which wasn't originally on the lathe when I got it, and when I fitted the clutch, I think it was about 2 years ago now, or nearly 2 years ago, I managed to find a really nice used clutch to fit to it, and it does make a big difference in using the lathe, because if you're probably aware of this anyway, you're machining a part and you need to keep stopping the lathe to make measurements of the part. Before this I had to keep switching the motor on and off, which is a capacitor start motor, is, I'm told, not very good for the motor. So having the clutch means that obviously I can keep the motor running and then just disengage the drive to the chuck. So it's improved my use and operation of the lathe a huge amount. Makes it sort of very much easier to work with now. There's all sorts of other sort of vibration noises. I did find sort of holding this, squeezing that cover in, that it quietens it down a bit as well. So I guess there's a degree of sort of vibration in areas of the lathe as well, and obviously most important with the Myford is keeping everything on the lathe oiled all the time. You have important oiling points here for the lower section of the lathe, and 2 oiling points up here on the counter shaft. There's another oil point here, and another one on the inside of the larger pulley here as well. Another important thing also with the Myford is that when you finish using the lathe, is to take the tension off the belt. That's done by, if you can see that with my arm in the way, is moving this lever up, so that you leave the lathe when it's not being used with the tension off the belt. It would be really lovely to have a variable speed motor on this lathe. I've seen or saw one of these over the years at the Model Engineering Show. There used to be a chap there demonstrating on a Myford lathe, and he had a variable speed motor on it, where you've got sort of constant control of the speed. and you could hardly hear the motor. It's absolutely whisper quiet, absolutely fantastic to have, but don't think that's going to happen. Anyway, let's close this down, tension off the belt, and switch the power off to the lathe. Well, I hope all that was of interest to you. It probably would be more interesting if I'd have shown you fitting the pulley, but as I mentioned, I found some sort of difficulties with it. I suppose I could have shown you machining the new keyway. I'd found a piece of this sort of, I think this is like a key stock, so I just sort of machined a piece down from that to the size. The keyway is approximately 7/16 of an inch square, but that's all done now, so I'm quite happy that I've got all that sorted. We'll move on. I'm going to go back to my desk because there's a couple of other things I'd like to show you as well, which I hope you might find interesting, so bear with. I also wanted to share with you a couple of viewer gifts I've received for the workshop. The first one is this very nice set. It's a Batty British made dial depth gauge. I'll bring you a little bit closer so you can see the gauge in more detail. Obviously it's something I've got to learn to be able to use. Previously I've used one of these familiar depth gauges. This is an Imperial Moore and Wright micrometer depth gauge, and I have used this quite a lot in the workshop. I suppose sort of most of you are familiar with this, but the one I've received is not familiar to me at all. I've not seen or handled one of these before. And then I also have this other depth device, I guess you would say more of a manual depth gauge. I bought this base part a few years ago. It was quite a number of years ago at a model engineering show, and one of the trade stands they had there was a box of all sorts of odd bits and pieces with a sign on it, £1 each for each item in it. I picked 2 or 3 bits and pieces up out of it, but had this as well, and it didn't have a rod for measuring depth, but I found this little ground shaft, and I've used this quite a number of times. Obviously you can drop this down into a hole or off the edge of a piece of material and just sort of let it drop to height and then lock it, and then you can make it a separate measurement. You know, handy for measuring the depth into a hole where you couldn't get a ruler and anything like that into the hole. So I thought for the cost of £1, I thought that was quite good actually. But I'll bring the camera in a bit closer so I can show you this new tool in a bit more detail. Bear with me just a second. This is what the set comprises of. You've got the main part here, the clock gauge, with a ground surface here, and obviously you've got the plunger which will set the dial. Hope you can see that okay. And it also comes with you can see here a number of extension pieces. The plunger here has a little part that can be screwed into the base, so that will give you sort of one depth measurement. By taking that out, you've obviously got a depth of measurement here. Now that measures, I did make some notes on this, this is a quarter of an inch, 250 thousandths, and you've got 3 other extension pieces here as well. These are 3/4, 1 3/4 and 2 3/4. Now the viewer that sent this to me said that really you need to set this up, just move that back a little bit, using slip gauges on a surface plate. Now I've got to say that I hope I'm getting the idea right with this, but this I measured as being 1/4 of an inch long, and this is 1/4 of an inch slip gauge. So by dropping that on, you can obviously set that dial accurately to the 0 position for 1/4 inch. Now if I add the the 3/4 inch extension, that's obviously going to, well, give me an inch depth, and using a 1 inch slip gauge, it should, we'll get that on level, it should read the same depth. So I assume that the idea is that, you know, once sort of knowing what the depth of the plunger is here, that you can make readings into, or setting it up with any of the other extensions, you can make readings into a hole or recess in a part, and then make adjustments, measurements using the dial gauge on here, because you've obviously got a dial gauge here. This measures in 1/2 thousandths, and you've got a second dial here, so you've got, you know, quite a wide range of possible measurements that you could make. Obviously a very, very accurate device, I guess, for measuring depth. So, you know, whether I'm getting the idea right or wrong, I don't really know. I mean, if anyone has any sort of advice on this for me that has one of these and has used one, I'd obviously be pleased to receive any comment or advice on it. But I thought this was such a wonderful thing, and I'd not seen one like this before, or handled one of this type before, and as I say, using my Moore and Wright one, I mean, will do much the same thing, but doesn't have the range that this one has. My Moore and Wright one would obviously only measure depths up to 1 inch, which is the extent that the micrometer shaft has itself, but this one obviously will allow you to measure up to 3 inches in all, the 1/4 inch here and the 2 3/4 inch of this extension. So I mean, you've got a much bigger range with this, so for some applications obviously it's going to be very, very useful indeed. But I thought you might like to see that. I'm very carefully move my slip gauges out of the way. I'm going to take this off because I'm going to show you the other gift I received, you know, quite separate from what I've just shown you. Just tip that down a bit. I'm putting this on here because I obviously don't want to damage my beautiful surface plate. But this is what I actually received today. It was 3 thread gauges, really nice ones as well. I do have thread gauges. One I bought a long time ago was an imperial thread gauge. That would be equivalent to this one. This is a Whitworth gauge. I guess this is quite old and probably a real quality item. It's engraved with I guess a stock control number on here for a professional workshop, but I don't know who made this particular one. But I'm guessing this is probably one made in England. The other two, I don't have equivalents to these. That the imperial one I have is a very inexpensive one made in China, but it does work very well. And surprisingly enough, I do use thread gauges quite a lot to try and work out what the thread pitches are on various screws. These other ones I haven't got. This one is made by Moore and Wright in Sheffield. Again, a sort of quality tool maker, but this one is American standard, so this will give you I guess, well, I might call them UNF and UNC threads. It has sort of a whole range here, quite a wide range of possible ones here. And the other one, which I'm going to find very useful, I could have done with this the other day actually. This one again from Moore and Wright, and this is for BA threads. And so this gives the whole range of BA threads. I must confess I didn't know that there was one of these available for BA threads. And also on here there's a bit of grease over that, is I think this is a tool setting gauge here to set the tool for if you need to screw cut a BA thread. I guess that's what that is. Almost certainly is. I think it says 47 degrees on here. So that's going to be very useful, because the job I did, which I showed you earlier, where I had to make a 0 BA grub screw, I could have used one of these to measure what the pitch of that was. And there it is. In fact, that's the 0 BA thread pitch. So it's really nice quality ones. Not saying that some things from China aren't of reasonable quality these days, but it's I'm a great fan of the tools made by Moore and Wright. I guess Moore and Wright is the American, is the British equivalent to the American Sterrett company, I guess. So these are very nice ones to have. I'm quite pleased to have those in my possession now, and I was going to make great use of them. They're in nice the Moore and Wright ones are in very nice condition. This one has some sort of staining on it, but it may just need a little spray of WD-40 and perhaps just going over each individual finger with very light Scotch-Brite cloth just to clean it up a bit. But I'll make sure these are nicely oiled, and I'll find a nice little box to keep them in my nice wooden tool cabinet. But I hope you found all of this of some interest to you. Let me just... But there we are, some very nice gifts that I've received. Considering my YouTube channel is very small, and I'm obviously not very well known on YouTube, it's very nice to receive these little gifts from viewers to the channel. They're nice little appreciation gifts. So there we are. I can wind this video up now and sit at my desk here and contemplate the next project that I've got lined up. During the Christmas period, I sat indoors and wrote up a list of all the projects that I'd like to do during the early part of the year. One is going to be, when the weather is a little bit warmer, is starting to make the nice steam engine kit that I was bought as a Christmas present. But there are lots and lots of other things that I want to do. One of the items that I've ticked off the list now is fitting the new motor pulley to the Myford Lathe. So that's literally one project out the way. But anyway, thanks for joining me in the workshop. Also, thank you for all the subscribers to the channel. If you haven't already subscribed, well, please do. I'd like to see the numbers go up. It's quite pleasant to see that. And also, thank you very, very much for all the nice comments to the channel as well, on hints and advice, and receiving that hint about the 0BA thread being basically the same as a 6mm thread was very, very useful to me. Something that I obviously store away in my memory bank. Anyway, thanks for joining me, and hopefully I'll have another video for you very, very soon. Bye bye for now.